So lab 3 is on matrix factorization for collaborative filtering in recommended systems. And so you can see that this is compared to the previous 2 labs, right? So it's a light lab, has only one task, as one section that you should really finish, right? So by Wednesday. And the previous 2 weeks should have laid the foundations of the basic programming in PySpark, right? So here, in this, from this lab, right? So we will focus more on the machine learning and the applications, right? So there are some quite good references right over here. This is the standard documentation. This is a tutorial, right? So there the GitHub page for the data bricks, link for the free cloud computing platform, right? So that you can sign out. You can sign up to try. You also you can learn more about collaborative filtering from Wikipedia. And this is the API, right? So API for the AOS, and you can also look at another example in the PySpark tutorial on stock portfolio recommendation, right? So, and here, right? So here I provide very good resources of learning PySpark API using via pictures, right? So, so this link, right? So it's for you. This is very helpful for you to understand the APIs, right? You can click for RDD API or data frame APIs, right? So this is one example for the flat map. It gives you the code and also, for example, this is what is this? Data frame. This is RDD, right? So I think without writing anything, it's RDD. This one is data frame, right? So these it gives you the different visual illustration, like what is map is doing, right? So what is flat map, and give you the corresponding code, right? So therefore, it's very nice for you to understand what is the difference, right? So of course, just be aware. I think they haven't updated much, right? So this is still an old version, right? Old version, but these things didn't change, I believe. Right, so partition. So these are the filter, right? So distinct, sample, union, right? So sort by key, right? So this is like a very good illustration, right? So for sort by key, right? Group by type, right? Lots of APIs that you can browse, right? Collect, right? So I think we have used that. Collect, reduce, fold, right? So aggregate, max, min, and so on, right? So, and this is data frame, right? Data frame APIs, the aggregation, yes, cache, cache just make copies, right? Cache, collect, as a correlation, count, as it is something we have seen, right? So the count. So this is very helpful, right? So you can browse through that. Okay, so lab 3 is about movie recommendation. And this time you can try to use a regular node, right? As I said, it really depends on which one is more crowded, right? So it's not necessary that the reserved code will give you more resources, right? So this time I just try, you can try the regular node. Right, so this is an API, right? So you can click this. This is parameters that you need to set, right? But many are defaults, right? So therefore, we are going to work on the movie length data, right? So therefore, you need to understand the data format, right? The data is given you like this, right? It's not given you as a matrix, right? Because we know it's incomplete, right? So giving you by a matrix is not a good way. The data set is formatted this way. You need to understand, right? So you need to understand that's user ID, the user ID, right? So that's item ID and rating and timestamp. Right, that's timestamp. right? So we are going to work on this very small database called 100K from movie lens, right? So you see you get the data reading, doing splitting, and create the data frame, right? So that's a rating, and after that you do an inspection. Oh, we get it in. That's a user ID, movie ID, rating, and timestamp, right? So it's data frame. Got a schema, and we do a random split, right? So with a seed. This time I set a seed, and we cache the data so that because there's lots of iterations, right? So we want to cache the data so that it be faster. It be faster. And I also show you this warning also occur on my HPC, right? So it's normal. And you can install the thing on your own computer if you want to fix it, right? But it's benign, right? So it's not something very bad, right? So it's just we don't have the most optimal implementation, right? So that's ALS, building code strategy drop, right? So then evaluation, so evaluation. And then following, right? So show you how to use it, right? Once you train the model, right? How to make recommendations, right? So that's some APIs. You can make recommendations for all the users and just show top 5, right? So that's the user you can see, right? So that's the ID and that's the score, right? So you can see the score actually is more than 5 here, right? So it's not exactly the range we have. This is recommending users. Let's recommend users. And we also have examples to help you to inspect the factors, right? For example, the item factors and the user factors, right? So, and also encourage you to use describe to see a summary of the data, okay? The movie, the exercise, right? So you need to do it on HPC. I want you to learn how to use the command wget, right? So I've shown you an example in lab 2. So you should be able to use this to download, right? Download this from this URL, use wget to download this dataset directly to your HPC, right? So not using a drag your file or transfer file from your local PC, right? But download directly from the internet and use unzip to unzip it as a Unix command, understand the data and perform the task, right? You can do some plotting, use some matplot, and finish this task, right? So in the additional explorations, I provide you some, because this is a recommender system, right? It's a very practical topic, right? So therefore you can do the tutorials over there. There's another set of solution, right? So for this quiz by DataBreak, actually they have a solution, right? So therefore you can solve that and compare your solution with the provided one. Or of course, it may be a little bit outdated in terms of API, right? So, but there's no much change, I believe. This is a Kaggle competition on Santander Bank, right? So product recommendation. And you can see some solutions and stock portfolio recommendation, right? So you can see whether you can make money from that. There's a very good example there, right? So this is a work done by our own MSc, who is a first batch students working on this is a very interesting evaluation, right, for time split recommendation. Okay, so that's all for lab 3, right? So that's all for lab 3 or something. Should be order S. That's all for lab 3, and that's all for session or week 3 sessions, right? So the lab is lighter, right? So therefore, it's very important for you to make sure that you have completed the fundamentals in lab 1 and lab 2, right? So lab 1 and lab 2 are the fundamentals, right? So if you have no problem over there, the lab, the following labs should be easy, right? So it's more about the technical content, about the models you need to understand. But in terms of programming, right? So it should be easy once you mastered the first 2 labs. It will just be a few more, like learn some new APIs, right? To try to check documentation, learn how to use it, right? So that's a learning process. Okay, I will stop here and I will see you on Wednesday, yeah, in the online sessions. Okay, bye bye.